Hi there, and welcome to Math Help for Algebra 1. Today we're going to be continuing looking at Unit 1, Variable Statistics, and today is Lesson 2 on data representations. So different ways of looking at data. So our learning goals real quickly for the day is we're going to be looking at how we represent and analyze data using dot plots, histograms, and box plots. Okay, so we'll get into those a little bit today. So dot plots, when you have little dots like this. Histograms, when you have kind of the bar things like this. And then a box plot, where you might have some numbers, and along that, you might have a little box looks like this, and some points along the way. So again, we'll get into that more as we go along. All right, and then your goal for the day, your learning targets, is you can find the 5-number summary for data, which that tends to go along with the box plots. And then also that you can use a dot plot, histogram, or box plot to represent different types of data. Okay, so let's get into this today and see what we have. We're going to begin, first of all, with a notice and wonder, looking at 3 different charts here. And it says the dot plot, histogram, and box plot summarize the hours of battery life for 26 cell phones constantly streaming video. What do you notice? What do you wonder? And so we have a couple things here. We notice, first of all, that over here we have a dot plot here. Okay. This one over here on this side, we would call this our box plot. Okay. Sometimes it's referred to as a box and whisker. Okay. In that one there. And then over here we have our histogram over here. So 3 different ways of representing the same information. All of them are representing the battery life for 26 different cell phones. So some things you might notice, some things you might wonder when you look at this information right there. Okay, so a couple things. We can see that there are certainly 3 different ways of representing the data information. The dot seems to be a way of just showing how each one, you have 2.5 hours here, for example. We can look quickly at the dot and see that here at 5.5 hours seems to be the most common battery life of all the data points there. We can see, looking at the box plot here, for example, we can also see there's kind of a spread that goes all the way from 2.5 all the way up to 6.5. So there's definitely a range of battery life expectancy here with the videos here. And when we look at this guy here, we can tell there's a big chunk kind of all right in the middle, right? Things you might just notice there, right? So box plot tells us, we can say, okay, it's a vertical line of symmetry. This one's not the same way there. Again, just interesting things. We can see 2.5 or 2, it's not a long time to last. That's pretty low there. So that's not a very good one, but there are a couple that last a bit longer, which is nice to see. All right, and just things you notice, things you wonder. All right, let's move on to the next page. So our first activity is on exploring a histogram. Okay, a tomato histogram. A histogram can be used to represent the distribution of numerical data. So we're talking about actual numbers here. We're looking at the numerical data. The data represent the number of days it takes for different tomato plants to produce tomatoes. Use the information to complete the frequency table. So this is our frequency table right here. And so we're going to use the information here to complete this table. So let's do this together here. We'll get out a nice little pen, and here we go. So from 40 to 50, we have 1 right there, so I'll put a 1 there. 50 to 60, we have, excuse me, 1, 2, 3, 4. So drop a 4 there. 60 to 70, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll stop there, because it's always hard to say. If 77, do they want you to include the 70? Probably want to go 69, so we'll just do 9 there. For 70 to 79, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 there as well.
I have your charger. It didn't even very charge that much, but it's okay.
Problem. All right, no problem.
Thank
Cool.
you.
Thanks. All right, and we're back. And for 80 to 90, we have 1, 2, 3, 4, 5, 6. We can put 6 right there. and then 90 or more, we have 1. So making a frequency table here, we can see we have 1, 4, 9, 9, 6, and 1, just using that information that was provided to us with the data points there for tomato plants producing tomatoes. Now it says in number 2 to go ahead and use the set of axes and in the information in your table to create a histogram. So a histogram is going to be more of that bar graph type of thing. Okay, so for example, we have 1 between 40 and 50. So if I'm going to come up to the 1, and what I'm going to do is draw up to the 1 line right there. 40 to 50 goes about there, right? I can change colors if we want to here. So between 50 and 60, I know I have 4. So I'm going to go up to my 4, put a mark right there, and draw 4. And there's my 4. Let's change colors. We have at 60 to 70, we're going to be at 9, so we're going to be way up here at 9. So there's that one there. And then for the next one, 70 to 80 is also 9. So we'll just go straight across. There's a histogram there. And I get another color. And let's go for 80 to 90, which is at 6. So we'll eyeball it here and go about 6. Fill that guy in there. And then from 90 to 100, we have 1. And so again, we'll be about here, and we'll fill it in there. So that becomes our nice histogram for the information from the frequency table. So all we've done is we've taken what was in the frequency table and we've converted it into a histogram. It's a nice way of just visually showing the data and information that was from the chart. Okay, so moving on. Now the histogram you created has intervals of widths of 10. It was like 40 to 50. Now the next thing says use a set of axes and data to create another histogram with interval width of 5. All right, so if we do this by 5s, we're going to have to change things up just a little bit here. So let's go ahead and do that. I'll just use one color for now. So if we have the 47 was our first one. So that's going to be between 47 and 50. So we have 1 there, right? And then between 50 and 55, we have 1, 2, and we'll just do 2 there. 55 to 60 or 55 to 59, 1, 2 there. And 60 to 64 is 1, 2, 3, 4. So we'll put a mark right there. And then 65 to 69 is 1, 2, 3, 4, 5. So one more a little higher there. All right, so we were at 1 here. We said we were at 2 there, 2 there, 4 there, 5 there. And 70 to 74 is 1, 2, 3, 3. And then 75 to 79 is 1, 2, 3, 4, 5, 6. About there. And 80 to 84 is 1, 2, 3. And 85 to 89 is also 3. And then 90 to 95 is a 1. Okay, so when we make this new histogram, breaking it down by kind of intervals of 5 instead of by 10, we can see that we have more data points than what we had before. We can see that the information is spread out a little further than we saw before. And so again, I'll flip back to what we had before. This one's a little more bunched together, right? A little more bunched here in this case here. We only have 1, 2, 3, 4, 5, 6 little bars. Whereas over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bars. So you can see the difference between the two there. Just by spreading it out, you can see a little bit more of the detail that comes with the data points that were provided to us. Okay, so the more bars we have, the shorter heights. It just shows that detail and what we might call the distribution of the shape in the histogram. Distribution means like how is it spread out. So that's what you can see when you change to a width of 5, like that one there. Okay, so that's our histogram using the data there. Now let's move on to talk about the box plot. Box plot. So box plot is a different way of organizing information, and you can see here we're going to be looking at the same data points again, and we can represent the data using numerical data using a box plot as well. So number one, it says use the same data as the previous activity for tomato plants, find the median and add it to the table. What does the median represent for these data? Okay, so median, right? I always like to think of this as like if I'm driving down a road somewhere, okay, and you probably aren't, maybe some of you aren't quite old enough to drive yet. The median is that like curb in the middle of the road that you don't want your car to go over. If you hit the curb, you're gonna pop out your tire. So median is a fancy word for saying it's the middle of all the information, okay? So our middle in this case here, when we look at what is the median is going to be the middle point. Well, we know that we can kind of draw a line. Oops, I'm on the wrong one, sorry. We can draw a line right here and split this in two, okay? So we have a total of 15 over here, and we have 15 points over here. And the middle is going to be then between, in this case here, between 70 and 72. Sometimes you have a number that is exactly in the middle, sometimes you don't. In this case, because there are 30 altogether, because there's 30, I'm going to just kind of split the difference and say the number that's going to be in the middle, my median, is going to be in this case between 70 and 72, which will be 71. So that's the middle point for this data. Oftentimes when I'm doing a box plot, it's actually kind of nice to write all your numbers in a long row so you can actually see where these are going to be at, okay? You know, to kind of get a feel for where they're going to be. But right now, we have them grouped up like that. That's okay. Not a problem. All right. Oops. All right. So here we go. Number two, find the median of the least 15 values to split the data into the first and second quarters. Okay. So what we're going to do is we're going to take a look at this part here, and we're going to find the middle of this point. Well, because it's 15, thinking numerically, we're going to have 7, and then we'll have 1, and then 7 more. That one in the middle is going to be the middle of this group here. So in this case, I can, let's get a different color real quick. I can go 1, 2, 3, 4, 5, 6, 7 that way. And then we can go 1, 2, 3, 4, 5, 6, 7 that way, leaving our median of the low part as 62. So that's going to be the middle point of our first and second quarters, okay? That's our middle point there. So quartile, we would call this kind of quartile 1, that at this value Q1, this becomes 62. That's the middle of this group of numbers right there. Now what it wants us to do is find the value of the third quartile that splits the third and the fourth ones together, which we'll call Q3. So let's get a different color out for Q3. Go ahead and get a purple one here. All right, Q3. And again, we're going to go 7, 1, and 7. So we'll count 1, 2, 3, 4, 5, 6, 7. And then from the back, 1, 2, 3, 4, 5, 6, 7, leaving our middle number of this section here as 78. 78. Okay, so we have our median, right? We have our median. We have the middle of the quartile 1, or the end of quartile 1 there. Okay, and then we have quartile 3 right there. The other numbers that are left are to define our minimum and our maximum. Now the minimum and maximum are going to be the smallest numbers that we have to work with. Okay, so our minimum in this case here is 47, and our maximum is going to be the biggest number, which is going to be 90. So these 5 points in this chart are what we're going to use to make in this case, what's called here a 5-number summary to create a box plot that represents the number of days it takes for these tomato plants to produce tomatoes. So what we're going to do here is we're going to make this. Let's see if I can do this nicely or neatly as possible. All right, so I like to start with the median, which is going to be 71. So I'm going to put a dot at 71. My quartile 1 is at 62, so we'll put the dot right there for 62. Quartile 3 is at 78, so we put the dot right there for that. Okay, and then we have our minimum at 47 and our maximum at 90. Those are our 5 points. And the way this works is we're going to draw our box. It goes around quartile 1 and quartile 3. And then we put a line in the box where our median's going to be at. And then we're going to connect our lines here. Oops, sorry about that. I moved. We're going to connect our lines here from our minimum to quartile 1 and there. And now we've made the 5-number summary with the same data point. Again, this is the same information that we had over here and that we had over here. Nothing has changed, the same data, just different ways of showing as a histogram with kind of a space of 10, histogram with spaces of 5, and now as a box plot with the 5-number summary. Again, what we can see with this here, the box plot also is easy to see where the minimum value is going to be. Okay, we can see right there the minimum value is down here. We can see where the median is going to be quickly at 72, and we can see a maximum. Okay, we can also tell that 71 is a typical number of days for the tomato to produce fruit, because that's the median, that's the middle number. So 71 is a good typical median number right there. Okay, so different ways of organizing the information, all right, whether it be a dot plot or a histogram or a, in this case here, the 5-number summary box plot. Okay, so in summary, the table shows a list of number of minutes people can, this example here, this is the table here. This table here shows a number of minutes people can intensely focus on a task before needing a break. 50 people of different ages are represented. In a situation like this, it's helpful to represent the data graphically to better notice patterns. So you can use a dot plot, right, to see the distribution of the data. So a dot plot shows the distribution, means kind of like how this data is distributed and spread out over time. Okay, this is how people are, how much can they focus before needing a break. And we can see here there's kind of a little space right here where definitely there's a little gap of something happening there, and a little gap there as well. Okay, and we can see time in minutes. So a lot of people can kind of get to 10 minutes and then, man, had a hard time, and then a little space there. So we can see with the information, there are quite a few people that lost focus at around 3, 7, and 13, and 19 minutes. So when they lost their focus, okay? So we have 3. So what they're having us look here is we're saying, okay, where people lost focus, that is the high points. So this is lost focus, 13 lost focus, and lost focus. So this is where people tend to lose focus there. Nobody lost focus at 11, 12, or 15 minutes. I guess those are the gaps there, right? So nobody lost focus there. Interesting. Okay, but dot plots are useful when the data set is not too large and shows all the individual values in a data set. In this example, a dot plot can easily show all the data. If the data set's very large, more than 100 values, for example, or if there are many values that are not exactly the same, it may be hard to see all the dots on a dot plot. So again, you have limited numbers. We're only talking about 50, so it's easy to show that there. The same data could also be shown as a histogram. So again, a histogram is another way of representing that to show the shape and distribution of the data. Most people lost focus between 5 and 10 minutes, or between 15 and 20 minutes. So we can see here where our high points at, between 5 and 10, 15 and 20. That's where most people lost their focus, was in that range. While only 4 of the 50 people got distracted between 20 and 25 minutes. So here's our 4 right about here. It's only 4 people there, right? When creating histograms, each interval includes a number at the lower end of the interval, but not the upper end. For example, the tallest bar displays values that are greater than or equal to 5 minutes, but less than 10 minutes. In a histogram, values that are in an interval are grouped together, although the individual values get lost within the grouping. A histogram can still show the shape of the distribution, meaning we can't see the individual values here, and that's what you're losing there. the individual values are lost. We can't see them. Over here, we can actually see, oh, here's the number 3, and there are 1, 2, 3, 4, 5 of them. Whereas over here, where are the 3s at, right? The 3s are somewhere in here, but they're all mixed up in this section. We can't see them. We can also, of course, represent this as the box plot as well. And again, what we can see in this case here is we can see where the median is going to be. The median is right here at 6, 7, 8 is the middle of all the data set there. We can see that quartile 1 is here at 6, and this one's over here at 17. We have a maximum at 20 and a minimum at 1. So we can use the 5-number summary to make a box plot to represent that same data. So for a set of data, the 5-number summary consists of these 5 statistics: the minimum value, the first quartile, the median, the third quartile, and the maximum value. These values split the data into 4 sections, each representing approximately 1/4 of the data. So that means that we're representing 1/4 of all the numbers in the set are in there. So, right? So 1/4 of the numbers are between here and here, 1/4 of the numbers between here and here, 1/4 between there and there, and 1/4 between there and there. Which makes sense because when you put it all together, 1/4 plus 1/4 plus 1/4 plus 1/4 equals 4/4, which is the whole set of data. Okay? All right, the median of this data is at 8 minutes, which 25% of the data falls in the short second quarter of the data between 6 and 8. Similarly, approximately 1/4 of the data is between 8 and 17 minutes. Like the histogram, the box plot does not show individual data values, but other features such as quartiles, range, and median are seen more easily. So all these provide us 3 different ways to look at shape and distribution while highlighting different aspects of the data. Okay, so if you're in class today, you might be doing a cool down. So again, if your teacher's doing this with you, probably will pause right here and do the cool down and really answer some basic questions about the different things between the dot, the histogram, and the box plot here. And so here's our dot, our histogram, and our box plot here with the same data. So really answering the questions: what are the strengths of each representations? What are the weaknesses? And how do you find what we would call the typical value for a data set? Okay, moving on to your homework for the day. Here we go. The dot plot displays the number of bushes in the yard for houses in the neighborhood. What is the median? Okay, we said before, median means what is the middle value. In this case here, I have one, I need to count them. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 points there, right? Which means I'm going to be something like 10 is about the middle, right? So somewhere around 10 is where I'm going to be, but I'm going to have, if I have 10, then I have 10 there and 10 there. My middle value is going to be like somewhere different, right? Think of it this way. I'm going to have 5, 5, 6, 6, 6, 7, 7, 7, 7, 8, 8, 8, 9, 9, 10, and then 11, 11, 11, 11, and 11. Those are my values there. So now what I need to do is I need to then figure out where the middle is going to be. So I could think of it this way. I can go 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. And you look here, I have 10, 10, right? Which means my middle is going to be actually in the middle of those values. This time, because they're the same value, 8 and 8, my median in this case is simply going to be 8. So 8 bushes is my median value for the data points here. Okay? So if you need to lay it out in a nice line like that, that might help you see things a little differently. Okay. The data represents the shoe sizes here of 19 students in 5th grade physical education class. Create a box plot to represent the distribution of the data. Okay, so for the box plot, I'm going to need to have my minimum. I'm going to need to have my quartile 1. I need to have my median. I'll need my quartile 3, and I need my maximum. So I need to find all these values here. Now, fortunately, they're all in order for us, so that's nice, makes it nice. So my minimum is here at 4. My maximum is here at 9. My median's in the middle, so I have 19. Because I have 19, that means I can sit here.
Excuse the interruption. T-Tax by the UHS sign in the front of the campus needs to come and retrieve their items. Once again, if you have a backpack that is unattended at the UHS sign, please get your items. Thank you.
So because I have 19 right here, that means I can go with 9 and a 1 and a 9. So my median is going to be the one between the two 9s, right? So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. And so my median number is going to be a 7. Now to find the middle of what's left, I look at the middle number here. And so I know that's my middle number, my median is 7. So my quartile 1 is the middle number of this section here. And what's the middle number of this section here? So same idea. And so we have, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go to 4 and 4. So this becomes my quartile 1 number is 6. And over here, same thing. We have 1, 2, 3, 4. 1, 2, 3, sorry, erase that. Oh, there we go. 1, 2, 3, and 4. And so my quartile number here becomes 8. So, and with that information there, what we can do is we can now draw our box plot to represent that same information. So we draw our number line. We can start over here at 3, we have 4, 5, 6, 7, 8, 9. We can label all those. Okay, and let's go ahead and we're going to plot our median here at 7. There's our median. We have our quartile 1 is at 6. Quartile 3 is at 8. Our minimum is at 4. And our maximum is at 9. So then with that information there, we can then connect the dots. All right, and we can say, there's our box, there's our median, and here are our ends showing the minimums and maximum. Okay, and that's our data set there for the 19 students in 5th grade PE class shoe sizes. All right, moving on, number 3. The data set represents the number of pages in the last book read by each of 20 students over the summer. Okay, so number of pages in a book. Create a histogram to represent the distribution of the data. So for this histogram, I need to think through what do I want it to be. I need to make myself a axis like this, right? Where I'm going to have the number of pages down over here, and then I'm going to have the number of students over here. So I'm going to group this up. I get to decide how I want to group this up here. Maybe I'm going to go by 50s. Maybe I'm going to go by hundreds. I think here, let's go by 50s. So I think what we'll do is we'll go, we'll start our top part, we'll start 0, and over here we'll start at 150. And then we'll go to 200, we'll go 250, 300, 350, 400, and 450. Okay, and for our numbers, we're going to go 0. We'll go 1, 2, 3, 4, and 5. Okay, so let's plot this out. Here we go. So between 150 and 200, we have a total of, in this case here, we have 1, 2, 3, 4, 5. So we're going to go up to 5 people. We're in this range right there. Now, in the next section, we have between 200 and 250. So let's get a new color. We already used green. Let's go with the orange. 200 and 250, we have 1, 2, 3, 4. So we'll go here at 4, draw our next bar right there, and then get another color out. 250 and 300, 1, 2, 3. So we'll get here at 3. Next bar there. All right, 300 and 350, 1, 2, 3. So same height as the one next to it, right there. And let's go red. Let's go 350 to 400, 1, 2, 3. Another 3. We're there. And then finally our last one, we have 400 to 450 is 2. Like so. All right, so that's what our histogram is going to look like to represent that data distribution for number 3. Something along those lines is the idea. Okay, and a little review here from the first lesson says number 4, to select each set of data was collected from surveys to answer statistical questions. Select all of the data sets that represent numerical data. Okay, well here we have a bunch of numbers, so that certainly looks like numbers to me. Here we have categorical, because they're yellow, red, blue, so no. Here we have 3, C is definitely numbers, D is definitely numbers, E is definitely numbers, F is categorical, and G is also categorical. Number 5. Is what is a typical distance a moped, here I have a nice little Vespa moped, can be driven on a single tank of gas? Is that a statistical question? So typical distance a moped can be driven. So we're talking about a distance. Now a distance is going to be a number, right? That's going to be some sort of number. And how far it can drive on a single tank of gas? Well, is there going to be variety there? Again, you're looking for 2 things, variety and either a number or a category. Well, this definitely has a number and it definitely has variety. So we would certainly say that yes, this is a statistical question, and the reason is because it has both a number that you're going to be calculating and it has some variety, so you get a variety of responses. All right, that's really it for today. Hope that was helpful for you and look forward to seeing you next time. Have a great day.